Hello guys, you're welcome to another YouTube video experiment. I'm David, a rollout support staff with Fundi Robotics. We basically train the enhanced STEM curriculum. You can call it the STEM curriculum in secondary schools and primary schools to enhance science learning in Africa. So today we're going to discuss the lemon battery experiment. Hope you've heard about this. So let's get started. So here with me I have a multimeter. A multimeter will help us check actually if our lemon battery will have voltage in it. And then here with me I have some lemons, and in these we have citric acid, which is going to be our electrolyte that is very vital in this experiment. In our experiment we shall also need two electrodes for the experiment to work. An electrode is any substance that can easily conduct electricity, and then an electrolyte, which is in our lemon juice, the citric acid, is any substance that can easily break up into ions or electrically charged particles. Okay, so with me I have two electrodes, and these electrodes are going to act as our terminals for the battery, for the lemon battery. So here with me I have a zinc plate, and this will take up the negative terminal of the battery, and then the copper plate, which will take up the positive terminal of the battery. So I'll represent these two electrodes with just a coin and a galvanized nail. This is a 500 shillings coin, and to act as our positive terminal of the battery because it's made of copper. And then this is a galvanized nail coated with zinc, which will act as our negative terminal of the battery. Then we also have the lead. I think you've seen this before. LEDs are basically low voltage, low current devices. When you take a good look at them, they have one lead shorter than the other, and then these are going to help us actually see if there is current flow from our lemon battery. So if there is actually any current flow, the LED will be able to glow. And then here with me I have some jumper cables or jumper wires with alligator clips that will help us connect the positive terminal of our battery to the negative terminal of our battery. So you remember we talked about us having an electrolyte and two electrodes, and these are the two electrodes. The copper coin will represent the positive terminal of our battery, and then the zinc coated nail will represent the negative terminal of our battery. And with me here I have a lemon that has an electrolyte in it. So the first step is for us to first roll the lemon on a hard piece of ground. Now to make it juicy, roll the lemon on our table until it's juicy enough. And then when you feel like it's wet in your hands, then we can insert the galvanized iron coated with zinc into one side of the lemon, like that. Okay, and this will represent our negative terminal of the battery. And then I can make a slit where I will insert the copper coin for our battery, and then I'll go ahead to insert the copper coin into the lemon, and there we go, and we have a lemon battery with a copper coin representing the positive terminal of the battery, and then the zinc coated nail that represents the negative terminal of our battery. So here we go, I have a complete lemon battery. We can prove it using a multimeter. So with me I will connect the positive terminal of the battery and then the negative terminal, and then you can see on my voltmeter it gives a reading of 0.948 voltage. So actually my lemon battery works. So what do we know about lemon batteries? So lemon batteries are actually unable to create large amounts of current that are used to operate most of the electronic devices around us, but There are some low current devices that can be operated with these lemon batteries. Take for instance the LED, which is the light emitting diode. And then we also have like some watches, those old watches that use round electric cells, can be operated using the lemon batteries. Then we also have some calculators, scientific calculators, by the old versions. So for this particular experiment, we are going to use the LED to actually test whether there will be any current flow in our lemon battery. So a LED has two leads. One is called a minus lead, and then another is a plus lead. So on this battery, on this LED, the shorter lead is the minus lead, and the longer lead, the one that I'm holding, is the plus lead. So here's what we're going to do. We shall connect our LED to the lemon battery using some jumper wires with alligator clips. So I'll go on to connect the minus lead to the negative terminal of my battery, which is the zinc coated nail. And then I'll connect the positive lead to the positive terminal of my battery, which is the copper coin. So I'll go on to do that. That's the negative lead, and I'll connect it to the negative terminal of my battery. And then I'll go on to connect the positive lead to the positive terminal of my battery, and that is the right connection, but my LED is not glowing. So what could be the reason? Because we have the right connections. I've connected the minus lead of the LED to the negative terminal. Then the longer lead, which is the plus lead, to the positive terminal of the battery, but I still don't have my LED lighting. So what could be the reason? The only reason as to why our LED is not glowing, it's because it doesn't have enough current flowing through it. So what shall we do to make our LED glow? We shall have to increase the voltage by adding another lemon to our circuit. And increasing the voltage implies we shall have more current flowing through the LED. So here's what we are going to do. So we have two lemon batteries in series. So this is very important to note. We connect the positive terminal of one battery to the negative terminal of the other battery, and then we connect the negative terminal of the first lemon battery to the minus lead or the shorter lead of our LED, and then we shall connect the positive terminal of this second battery to the plus lead of our LED. So rearranging, you can see that this is a series connection. So when I observe very keenly, I can see there is a tiny glow. So what we shall do to increase the current flowing through our circuit, we shall have to add maybe more two lemons in series to have a higher current flow that will be able to make our LED glow brightly. So we can go ahead with that. Okay, so now we have our 4 lemons connected in series, but make sure that you connect the positive terminal of the first battery to the negative terminal of the second, and then connect the positive terminal of the second battery to the negative terminal of the third, and then connect the positive terminal of the third battery to the negative terminal of the fourth battery. So with our 4 batteries connected in series, we shall first check, first of all, the voltage that is in our lemon batteries. So I just have to connect a multimeter to the positive terminal of my 4th battery, and then I also connect this wire to the negative terminal of my 1st battery. And when you check on our multimeter, we have approximately 3.8 volts, which is approximately 4 times the voltage we obtained in our 1st battery. So with this, with a voltage of approximately 3.8, we should be able to light up our LED. So let's try and see. So we are connecting the positive terminal to the plus sign, plus lead of our LED, which is the longer lead, and then we shall connect the negative terminal. So when I observe very keenly, I'll notice a very bright glow of my LED. If you're able to look closely, you'll see your LED lighting because you have a bigger voltage, which allows more current to flow through your circuit. Yeah, and that's our lemon battery. It has been able to light up the LED because of having a higher current flowing through the circuit. In summary, the electricity is not coming from the lemon, but from a chemical reaction resulting from the differences in electronegativities between the zinc-coated nail and the copper coin. The electrons would rather be in the copper coin, and the lemon juice opens up a door for them to get there. So guys, thank you for joining us today. If you enjoyed the video, please like and subscribe. And if you have any questions or any comments, please comment in the comment section below. You can join me for some lemonade. Otherwise, have a great time. See you next time. Bye bye.